Hello. In this video, we will cover section 4.1, which is on scatterplots. The principal tool for examining two variable relationships when both variables are numerical is the scatterplot. In a scatterplot, each point represents one observation. The location of the point depends on the values of the two variables. All right, so here you can see a scatterplot that has 51 points as the 50 states and the District of Columbia. Each one of those points is the coordinates, right, where the x-axis, x coordinate is treated as the median age of marriage for women, and the y coordinate is treated as the median age of marriage for men. When studying scatterplots, we look at three things: trend, strength, and shape. The trend of a scatterplot is the general tendency of the scatterplot as you look from left to right. If there is a trend, then we say that the variables are associated. Trends are typically either increasing or uphill, right? And this is supposed to be an uphill, shows the trend to go up as you go from left to right, or decreasing or downhill. And this is showing a downhill, you're going down as you go from left to right. Increasing trends are called positive associations or positive trends, and decreasing trends are negative association or negative trends. All right, the scatter plots on the next page show a positive association or a positive trend and a negative association or a negative trend. So here we have the positive association or the positive trend and a negative association or the negative trend, right? So you go up as you go from left to right, you go down as you go from left to right. It is also possible to have no trend. If there is no trend, then the variables are not associated. This can be interesting when you expect a trend. For example, we tend to associate physical performance with youth, so you would expect to see a trend when comparing marathon time to age. However, that isn't the case with the marathon results shown on the left side of the next page. Finally, it is also possible to have changing trends. The image on the right side of the next page shows the simulation of a trend that changes from a negative trend to a positive trend. Right, so these are the marathon results, and if you look at that, there is no discernible trend there. Right, it's difficult to see anything. All right, so that just shows that there is no trend between age and time when it comes to marathon results for this specific marathon, the Forest City Marathon. And then the second shows a changing trend. We have a downtrend that changes to an uptrend, or a negative association that changes to a positive association at around 0. The strength of the association is the amount of scatter in the scatter plot. The amount of scattered is measured by the amount of spread in the vertical direction. A strong association will have little vertical variation in the scatter. A weak association will have a lot of vertical variation. The images on the next page show weight versus height and weight versus waist size. Which would you expect to be stronger? So here we can see height and weight, and we have a clear uptrend. Waist size and weight, we have a clear uptrend. The vertical spread here is roughly this distance. The vertical spread here is roughly this distance. So the vertical spread in this example is clearly smaller. And so waist to waist size, waist to weight has a clearer association, a stronger association than height to weight, right? And that does make sense because height to weight, you could have people who are very thin and have a given height, or very heavy and have a given height. The shape of the association is the geometric shape of the trend. A linear trend has the shape of a line. All right, that is going to be the focus of this chapter. So we're going to be focused on linear trends. Okay, and you can see here are the dots, and you can see there's that they cluster around a line, and so that gives us a linear trend. There are trends that are not linear, and below is an example of one, and we will not be looking at nonlinear trends in this course. All right, you can see the dots here, and they cluster around a curve rather than a line. Okay, so we're not going to be looking at nonlinear trends such as this in the course. Let's look at a homework example. The first scatter plot on the next page shows the years a person was employed before working at the company and the salary at the company. The second scatter plot shows the years employed at the company and the salary. Which graph shows a stronger relationship and would do a better job predicting salary, and why? All right, so if we look at our two examples here, so this is years employed before working at the company and their salary. Okay, and there's the association is even kind of difficult to tell here. Maybe there's a little bit of an uptrend here, but it's a little bit hard to tell. Meanwhile, here we have years employed at the company and the salary. And this is much clearer that there is a positive trend here. All right, and certainly the strength of the association, which is going to be the width here, is definitely smaller than the width, for this guy. All right, and so this example is the stronger association and would do a better job of predicting salary. And I believe that that's exactly what I put here. The years employed at the company shows a stronger relationship because the vertical spread is narrower. Let's look at another one. The scatter plot shows data on age and GPA for a sample of college students. Is the trend positive, negative, or near zero? And why? All right, so if we look at this, do you see a trend? I do not. There's not much of a trend here. And so if there's no trend, then we would just say that the trend is near zero. And the reason is that we can just say that there's no discernible pattern. Right? You don't see it going up as it goes from left to right, or down as it goes from left to right. Instead, it's just a bunch of dots that are just kind of clumped all together. And let's see, what do we put here? The trend is near zero. The reason there's no pattern as age increases. Nope. And that's pretty much it. That's pretty much what I said. All right. Thank you for watching, and I will see you next time.